The first memory storage elements that we looked at was latches. Basically, latches are asynchronous components, which means that as soon as data is available at the input of the latch, your output is going to change. The second property of a latch is that it is level triggered. Level triggered in the sense when your input level changes, that is, if it changes from logic 0 to logic 1 or from logic 1 to logic 0, the outputs are going to change. That is what is meant by level triggered. So you can assume latches as several soldiers who are in a battlefield. All these are latches, or let's say soldiers. And as soon as the soldier sees an enemy, the soldier is going to fire at the enemy. So basically, if this particular soldier sees an enemy, the soldier is going to fire. So as soon as you receive a stimulus, you're going to create a response. So your latches, as soon as you see a change in your inputs, you're going to see a change in your outputs. The second type of memory elements are known as flip-flops. Flip-flops are synchronous components and they are edge triggered. So taking the same analogy, let's say your flip-flops are soldiers. The way the flip-flops operate is they're going to have a commander, and the flip-flops are only going to generate a response if the commander says fire. So the commander is going to control all the flip-flops or all the soldiers. Only upon giving a certain command, the soldiers are supposed to make a response. That is what I mean by synchronous. So depending upon this commander, the flip-flops are going to make a response. So the question is, how do we create this synchronous component, or how do we create this commander? This synchronous component is known as a clock. You have already seen what a clock is. So if you open up your operating system, you will get something like Intel i7 processor with 16 GB RAM, for example, working at 2.4 gigahertz. So this 2.4 gigahertz is known as the clock. So if your processor is working at 2.4 gigahertz, which means that it's going to have 2.4 times 10 power 9 pulses in 1 second. And the pulses are as follows. So for a 2.4 gigahertz clock, within 1 second, you're going to have 2.4 times 10 power 9 of these pulses. This is known as the rising edge of the pulse. So rising edge. And this is the falling edge. So in this particular example, you have 1, 2, 3, 4 rising edges, and 1, 2, 3, 4 falling edges. Your flip-flops can either be activated by a rising edge of the clock or the falling edge of a clock. Hence, it is known as the edge-triggered component. So synchronous, that's number 1, and then edge-triggered. For the latch, you have asynchronous and level-triggered. So that is the fundamental difference between a latch and a flip-flop. So in flip-flops, you can have rising edge triggered flip-flop, or you can have a falling edge triggered flip-flop. Sometimes the rising edge trigger flip-flop is also known as the positive edge triggered flip-flop, and the falling edge triggered flip-flop is also known as the negative edge triggered flip-flop. They are one and the same, and these terms are very interchangeable. Let us see how we can construct some flip-flops based on this knowledge.